Okay, let's look at what we have today. Let me write a fraction here for you. 4 over 5. That's a fraction. Okay? We'll be doing something with 4/5 in just a second. Let's read what I've written here for you. Two fractions are equal or equivalent if they are the same point on the number line. We have made many observations on the number line that sometimes a point has two names, two fraction names. And when it does so, we say those two fractions are equal, or I've also taught you this word equivalent. We can say the same thing. Okay? So here I have this 4 over 5. I would like to create another fraction. I want to come up with another fraction which is exactly equal to 4/5 or equivalent to 4/5, whichever word you prefer. How do we do that? Do you guys remember what we've been talking about? How do I create another fraction that's exactly equal or equivalent to 4/5? In the sense that whatever you tell me that is, if I were to plot this and this on the number line, they must be the same point. Let's think. We had a fact. It was FFFP. FFEF, sorry. Fundamental fact about equivalent fractions. Do you remember what that said? That said, if you have a fraction, that fraction is unchanged. It's going to be exactly the same if you were to multiply both the numerator and the denominator of the fraction by any non-zero whole number. So if I want to create an equivalent fraction, all I need to do is think of some favorite whole number. So I'm just going to pick 10. And if I multiply 4 by 10, I'd get 40. And I must now multiply 5 also by 10. I'd get 50. And our fundamental fact tells you, no worries, 40 over 50 is exactly same as 4 over 5 on the number line. Now this is because of the big numbers, it would be hard for us to check whether 40 over 50 is exactly same over 4 over 5. And if you, in a different video, we actually checked it for smaller numbers and then we came up with FFEF, which has been proved by a mathematician, which tells us, go ahead, anytime you have a fraction, if you don't like how it looks, multiply the top and bottom, numerator and denominator, by the same whole number. You'll get a new fraction, which is exactly equal to the old one. So you might find it a fun activity to start with another fraction, 4 over 7, and create lots and lots and lots of equivalent fractions. So in fact, let's go ahead and first multiply numerator and denominator by 2. Then what do you get? 8 over 14. Multiply numerator and denominator by 3. Then what do you get? 12 over 21. Multiply numerator and denominator by 5. What do you get? 20 over 35, and so on. So 20 over 35 is exactly same as 4 over 7. Same thing, same equivalent fractions. Some people may say I prefer 4 over 7, which has smaller numbers. That's fine if that's their preference. But mathematically speaking, 20 over 35 is exactly equal to 4 over 7. Okay? Now I want to do one more quick application of fundamental fact about equivalent fractions. So let's look at what I have here. I have the fraction 8 over 9. Okay? Says I don't really like the looks of this fraction. I don't really like the 9 here. Can I write another fraction which is exactly equal to 8 over 9? That means equivalent to 8 over 9. And it just won't have 9 in the denominator. In other words, I would like to write a fraction which actually has 36 in the denominator. And I want you to tell me what to put out here so that we can see this fraction is exactly same as that fraction. That's what I would like. What can we do? Well, let's think about the fundamental fact about equivalent fractions. What does it say? It says here's a fraction. It's fine to multiply both top and bottom, numerator and denominator, by the same non-zero whole number. So let's think. 36, 9. What's the relationship? 9, 36. Let me see. Let me count in nines. Counting in nines, if you don't know your 9 table, is adding a 10, going down by 1. So let's do it slowly. 9, 18, 27, 36. It sure looks like if you multiply 9 by 4, we get 36. Fundamental fact of about equivalent fractions tells us, feel free to start out with 8 over 9 and multiply numerator and denominator by 4. If we did that, what would we get? 9 times 4 is 36. 8 times 4 is 32. So what we're saying is 8 over 9 is exactly the same as 32 over 36. So we're finding out we can rewrite a given fraction as another equivalent fraction with any denominator that's picked, as long as we can find out if this first number goes into that one. So let's look at this example. 2 over 3. I'd like to write it as a different fraction. What kind of a fraction? Where I have 15 in the denominator. And now I want you to guess, what should I put here so that this new number that you tell me over 15 is really equivalent to or equal to 2 over 3. So again, it's fundamental fact about equivalent fractions which tells us, okay, we have 2 over 3. No problem. Anytime you want, you can multiply numerator and denominator by the same whole number. And the new fraction you get will not be really a new fraction. It's going to be exactly equal to the old fraction. That means if you plot them both on the number line, it will be the same point. So let's look again. 3 and 15. Is there a relationship? I think there is. Let's count in threes. 3, 6, 9, 12, 15. So it sure looks like 3 times 5 is 15. So if we were to multiply numerator and denominator by 5, then we would definitely get a fraction, a second fraction with 15 in the denominator, and numerator would be 10. And the fundamental fact about equivalent fractions will guarantee us that 10 over 15 is exactly equal to 2 over 3. Now you might ask, why would we want to do that? And we'll discuss that in another video. Why sometimes we would want to write a given fraction as a different fraction with a denominator that we actually have in mind. In fact, I'll even tell you we're going to use this when we have to add two fractions whose denominators are not the same. We'll discuss that in another video.